From the beautiful studios of Way Happy, this is Mr. Meyer, and we are talking angles of rotation. Now, how do you measure an angle? It is very important. Talk to snowboarders, talk to skaters, talk to anyone who has to measure an angle, and they will tell you that figuring out the angle is awesome. And how do we do it? Well, we start like this, right? Here's our axes. This is 0 degrees. Straight up is 90 degrees. This is 180, in fact, facing the exact opposite way. 270, and then all the way around is a 360, and that's one of the sickest moves in sports. All right, how do you measure it? You start off with your what's called initial side hanging out in the direction of 0 degrees. That's where you're going to measure from. That's called standard form. And we are going to measure our angle going, if we go around this way, we are going in what is called counterclockwise direction. And you can see as I go around in that motion, it's like right about here I'm about 30, here I'm about 45, here I'm about 60, there's 90, here's, another 30. And that's, let's say this is, 125 degrees. That's how I measure how far something turned, right? You can put your protractor on top and you can measure it and get it exact. And that's what we like. So we're always going to measure from standard position, starting at 0 degrees to the right, and then we're going to measure in a counterclockwise direction. Now you can measure, if you notice here in my slides, you see the positive rotation right here, like we just talked about, but you can also measure in a negative direction, which just means you're going the other way. Instead of going up, you're going to start measuring down. You're going to go down this way and find an angle down here. So that would change this 270 now all of a sudden becomes negative 90 degrees. The 180 now all of a sudden becomes negative 180 degrees. And the 90 becomes a negative 270 because I'm spinning in a clockwise direction. So you got to be careful. Negative angles clockwise, positive angles counterclockwise. So let's try it. Let's draw a couple angles here so you can see what I have in example 1. I want to draw some angles. So let's find out where 320 degrees is. So here we go. This is 0, this is 90, this is 180, and this is 270, and 360 all the way around. Oh, we're just shy. We're somewhere between 270 and 360. So here's where it started at. That's really good. And 320 is like down here somewhere, right? And so this would be 320 degrees. And that would be your drawing. I'm measuring here, and I'm going 90, 180, 270, 320. Now, somebody might be saying, wait, couldn't we have just measured in the negative direction? Yes, we could, but that would have a negative value. That would be called negative 40 degrees. So negative 40 degrees and 320 degrees look exactly the same. That is called coterminal, and we'll get to that in a minute, but they do look exactly the same. Whether I drew it as a 320 or a negative 40, they look identical. All right, well then what's negative 110 look like? Well, here's 0. Right? We always start with 0. This would be negative 90. This would be negative 180. So it's not quite that far past negative 90. So I start here and I start measuring in the negative direction. And I'm going to stop about here. Yeah, I'm kind of ballparking, right? I'm trying to have an educated guess. And this is about a negative 110 degree. All right, what about 990? What? You're like, that's crazy, right? Well, it is a little bit crazy, but it's doable. So here we go. I'm going to start in this direction at 0 and watch what happens. And snowboarders are just going to, they're just going to be like, yes, we got it. So I'm going to go all the way around in a circle. That was 360 degrees. But we're got to go higher. So I'm going to go all the way around in the circle again. And that is now 720 degrees. So I'm like, holy macaroni, well, keep going. Another 90 to that is 810. Another 90 to that is 900. Another 90 to that is 990. And that's where I wanted to end. So there she is. There's my angle. Now look at the red lines. That's really the angle that we're talking about mathematically. So notice that looks like a negative 90 degree. It looks like a 270 degree. You're right. It is mathematically, but a snowboarder would tell you, no way. I did 1, 2, almost a third revolution before I wiped out. So you kind of enjoy that, and that's how we measure angles. Make sure you go in the positive direction. You know the difference between a positive measure and a negative measure, and you'll be feeling pretty good. Now here's that thing I was talking about, coterminal angles. I said up here that -40 and 320 were coterminal, right? And just here on this third example, I said 990 looks exactly like -90, which looks exactly like 270. And so all of these would be called coterminal. And so a nice thing about coterminal, it's kind of easy to find. Coterminal just means, hey, look, you can add a full revolution or subtract a full revolution, and the drawing of the angle will look identical. So coterminal just means, hey, you can add or subtract a 360 degree, and no one would mind. And you can do it as many times as you want. So you see a lot of people put like a number back here, like K or N or something, saying you can add 360s 5 times if you want, if K is a 5. So find a measure of a positive angle and a negative angle that are coterminal. So if I have 65 degrees, I can just add a revolution, and that would get me 425 degrees. Or if I want, I can take 65 degrees and I can subtract a revolution, and that, my friends, would be negative 295 degrees. And that would give you two angles that are coterminal with 65. In other words, if I draw a 65, a 425, and a negative 295, all look the same. Yeah, crazy is right. What about this other one over here? 410. 410, same thing. You know, I can subtract a 360 or add a 360. Now, I'm going to subtract a 360 because what is that going to give me? That's going to give me 50 degrees. Notice they wanted one positive and one negative. Well, here's my positive, even though I subtracted a 360. You could have added 360 and got 770, and that would have been fine, and no one would have complained. But I wanted to go down because guess what? I have to subtract again. So I'm going to take that 50 degree that looks exactly like a 410. I'm going to take the 50 and I'm going to subtract a 360 from that, and that's going to give me a negative 310. And I'm going to tell everybody, hey, 50, negative 310, and 410 all look the same. Co-terminal angles. Enjoy that. Let me ask you a question, and I'll be right back. Nice work on the coterminal angles. Now let's talk about a favorite one of mine and a very important one. Very. Reference angles, right? Trig is going to be super helpful for us, but you got to know your reference angles. Now the easiest thing to know about reference angle is this. This is called the 0 and the 90 and the 180 unless you're going the other way around. But I'm going to call it the x-axis and the y-axis for a second. It's kind of illegal, but this is your x-axis. The reference angle is after you draw your angle in standard position. Can you tell me how many degrees it is to the x-axis, to either 0 or 180? Now the trick is your reference angle is always a reference angle. Angle is always less than 90 degrees, right? It's always less than 90 degrees. So make sure that you never give me one that's bigger than that. So that it always goes back to the x-axis. So here we go. I'm going to draw 135 degrees, which we know. Here's 0. 90 straight up. 180 is over here. So 135 is like over here somewhere. So that's 135 degrees. Now the question is the reference angle. It's always a positive number. It's always less than 90. It just says between 0 and 90. And my question would be is this. How many degrees is it to the x-axis? Just give me how many degrees, right? That's very important. You've got to be able to do this. You never go to the y-axis. You always go to the x, and it's always the smallest one. It's always less than 90. In other words, I don't want to do this long angle here. I don't care about that. I know that's 135. I want to know this guy right here. How long is he? Well, if this is 180, then a quick subtraction tells me, hey, reference angle is 45 degrees. Done. Positive between 0 and 90. I'm golden. All right, let's do negative 105, number B here. So if I'm going to graph B, let's see, here's where I'm going to start, 0, negative 90, negative 105 is like right here, negative 105. Now my question is, again, get me back to the x-axis, and it's got to be the shortest way, so don't go traveling to the right, the 105 way, because that's more than 90. It's got to be this little guy right here. How many degrees is that? Well, again, if this is negative 180 and that's negative 105, what's the difference between them? And I think that's a good 75 degrees. So there's my reference angle, 75 degrees. This is a 75-degree angle right there. That's called my reference angle. All right, let's try one more time. Try 325. If you want, stop the video. Yeah, heck, I wouldn't mind. All right, you probably didn't, but where is 325? So now I'm going to go ahead and plot 325. So it starts off at 0 and it goes all the way to, let's see, 270. So it's a little bit past it. It's like here-ish, right? It's like 325-ish. Now the question, what is your reference angle? Again, back to the x-axis, so that would be this guy right here. I'm not going to go traveling all the way this way because that takes too long. And I'm not going to the y-axis. That would just be insane. No one would do that. So make sure you're always going to the x-axis. How many degrees is that? Well, it's just 360 minus 325 if I look at my drawing. So what is that, 35 degrees? All right, that's your reference angles. Make sure you can do those because it makes your life easy later on. So make sure you're always going to the x-axis and make sure your answer is always less than 90. Now a 90-degree angle, some people will call that a reference angle of 90 degrees, and I have no problem with that. So if you want to say that, that's fine. So if you have like a 270 or a 90, likewise, if you have a 180-degree angle, your reference angle would be 0. And that's okay. Some people say yay, some people say no. All right, what about this? How about I give you a point and you tell me the 6 tricks? So let's see real quick. You can read that beautiful box or just use your logic, right? So here we go. I'm going to plot the point negative 6, 9. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. That is right here. Now this is why reference angles are important. Draw the triangle that represents that point. So you're always going to connect it to the origin, first of all. That's really important. And then you're always going to connect it to the x-axis, never the y-axis. There's no y. It's like, you know, that song, Bass, no y. It's all about the x-axis, about the x-axis, not y. It's all about the x-axis, about the x-axis, not y. Okay? So don't ever let that happen. Now find your 6 trigs. Well, look at this beautiful triangle we made. This we know is left 6, so let's call it negative 6, even though distance is, you know, positive. And we went up 9, so positive 9. Here's our angle that we talk about. So all your opposites and adjacents and all that are there for you to know. And you know a little Pythagorean theorem says a squared plus b squared equals c squared. So holla, you know, if I want to figure out what that hypotenuse is off to the side, I got 9 squared plus, if you want, negative 6 squared. So was that 81 plus 36, 8, 9, 10, 11, 117 square rooted. So this is the square root of 117, which I think that's divisible by 3 and something, because I think 40 is 120. Yeah, so 3 and 39. Ooh, look at that. 3 and 13. So that's the same thing as 3 root 13 if you're keeping score at home. So I'm going to call that 3 root 13. All right, now using this angle that we have right here, our reference angle, we can go ahead and tell you everything. Sine of the angle is the opposite over the hypotenuse, or 9 over 3 root 13, which will reduce that and make it 3 over root 13. And we don't like that, so multiply top and bottom by root 13. 3 root 13 over 13. And there is your sine. Your cosine is adjacent over, now notice the negative comes into play here, adjacent over hypotenuse, which again, that's going to reduce to 2 root 13. And again, we don't like that root 13 in the bottom. So negative 2 root 13 over 13, and you've got yourself the cosine. And then our good friend tangent. And tangent would be opposite over adjacent, which is negative 3 over 2, and we jump them down. And now, if you want to, you flip these bad boys, and my advice to you, for cosecant, flip that one. For secant, flip that one. And for cotangent, flip that one. Dunzo! Thank you for SOHCAHTOA. Now you see why we have SOHCAHTOA so highly regarded. And I think we're golden. Now again, you could have gotten all those answers up here. If you wanted to do sine, you could have just done y over r, which is really what we did. And so if you want to memorize those formulas, great. If you just want to remember SOHCAHTOA, great. Always draw a picture. It will make your life easy. Have a great day. Stay happy.